Module 13, Lesson 4 covers dilations. According to the textbook, this is still going to be a one-day lesson. There's 15 resources to get through. I don't know. We'll see how it ends up going. A microscope enlarges objects that are too small for the human eye to see and are used in a variety of ways. For example, scientists use microscopes to study the structures of molecules of tiny organisms such as bacteria. Medical professionals use them to examine cells of the body in order to understand how different diseases work. Some microscopes can magnify an object up to 1,000 times its size. And I don't know what tiny little thing, that looks like a man-made thing they're sticking on a cell or something. That's a tiny little man-made thing to be able to see it like that on a cell. Scientists use microscopes to enlarge views. Yep. Photographers use zoom. Yep. What are some of the careers in which tools are used to enlarge or reduce objects in size? All kinds of stuff out there, guys. Let's move on to the actual lesson today. A dilation is defined as a transformation in which is similar to a scale drawing. Okay, that's a pretty weak definition from there. And it uses a scale factor to enlarge or reduce a figure proportionally. Now, they didn't actually define scale factor at that point. They define scale factor here when it says that is a ratio of the side lengths of an image to the side lengths of a pre-image. The pre-image and the image are going to be the same exact shape, but not necessarily the same size in the dilation. If the scale factor is going to be greater than 1, that means the image is enlarged. As you can see here, triangle ABC enlarged to triangle A prime B prime C prime. If the scale factor is between 0 and 1, that means the image is going to be reduced. So if the scale factor is equal to 1, that means the image and the pre-image are going to be exactly the same size. There's no negative scale factors here. Cannot happen. The scale factor of the dilation shown is found by using the ratio of the side lengths of triangle A prime B prime C prime to triangle ABC. Notice they took the image triangle, the new one, and put it before the original or pre-image triangle right here. The notation CB represents the length of line segment within point CB. So C prime B prime had a length of 4 that you see right here. CB had a length of 2, you see right here, and that means the scale factor, 4 divided by 2, that's going to end up being 2. Now we could also write the ratio of C prime B prime to CB as 4 to 2 that you see right here, which is also going to be known as 2. This means the scale factor, once again, to dilate the figure is going to be a scale factor of 2, and since that scale factor is greater than 1, we know it was enlarged, and we can actually visually see this. It became a larger image here, right? So, moving forward from there, we can see triangle RST was dilated to triangle R prime D prime S prime T prime, and taking a look right here, do you think that scale factor is going to be greater than 1, equal to 1, or less than 1? It's going to be a number less than 1 because we're going from a bigger figure to a smaller figure. We're going to zoom back in over here, and we're going to say to find the scale factor or the ratio of the image's side length, side R prime S prime, to the pre-image's side length of R and S. I should point out, it doesn't matter which sides you pick as long as you're using what we call corresponding sides, meaning they have to be in the same relative position in the two drawings. When we plug that in, the new image is going to be 6, the pre-image is going to be 8, that simplifies to be 3 to the 4th, and that's all the further you have to take it. It's written as a fraction lowest term. The scale factor is 3/4. 3/4 is a number less than 1, so we know that the image is going to be shrunk when it dilates. We have an inquiry question here that says, how does the scale factor change the size of the coordinates if of a figure after the dilation of to the origin. If we were taking a look at a figure on a coordinate plane, we've got quadrilateral, which is a trapezoid, and that's trapezoid B, C, D, E. You go in an alphabetical order, and it asks, suppose you dilate the figure by a scale factor of 0.5. Do you think the image after the dilation is going to be larger or smaller than the pre-image? Well, 0.5 is a number less than 1, so it's going to be smaller. And we can actually see that right here when we hit show the dilation. Our new image is going to be smaller than our pre-image. The question now asks, what other values of the scale factor will decrease the size of the figure? Pretty much anything less than 1. That's going to end up decreasing the size of our figure. Next, we're going to take a look at, it says show the dilation to show the coordinate, drag points to new. Alright, what we're going to do now is I want you to focus on what happens to the coordinates. Now remember, we multiplied by a scale factor of 0.5, meaning we half the size of the image. If we show the dilation, it's right there, but I want you to look at what happened to the coordinates. The coordinates ended up becoming half of the coordinates they were. 5 became 2.5, 6 became 3, 5 became 2.5, 2 became 1, and so on throughout all the coordinates on that coordinate plane. So when we dilated it, we not only shrunk it in size, we also changed the location of it on the coordinate plane because we cut it by half. 0.5 is half. We took each point on the coordinate plane and took their values by half as well, and that's how you know where to plot the points for your new image. Now the same thing's going on this image, only this time we have a scale factor of 2. 2 is a number greater than 1, so is our new image going to be bigger or smaller? That new image is going to be bigger. Look at that. Wow. It just got a whole bunch bigger, and you would think that that's not necessarily twice the size, but if you took and followed around to the points, let's move on to the next slide here, and we're going to show that dilation again. And what happened to each of the points on the coordinate plane? They all doubled because we had a scale factor of 2. We took each number that was in the coordinate plane, multiplied it by 2. 2 times 2 was 4. 6 times 2 was 12. 6 times 2 was 12. 5 times 2 was 10, and so on, all the way through the chart. Let's keep moving with our lesson. A dilation is a transformation that enlarges or reduces a figure by a scale factor or relative point of center. That point is going to be called the center of the dilation. New vocabulary term. We're going to select each card to learn about the coordinate notation or the dilation of the coordinate plane when the center of dilation is going to be the origin. So when the center of dilation and the coordinate plane is the origin, each coordinate of the pre-image is going to be multiplied by the scale factor k to find the coordinates of the new image. And we just saw us doing that on the Explore activity we just did. We can see that on the graph right here, where they took and multiplied the value of each point by, looks like 2 in order to get the new image. With variables, we can see that the pre-image coordinate of x, y is going to become the scale factor k times x, comma, scale factor k times y to get to your new coordinates location. Now it asks, why is our k value going to be 2 here? Because we have doubled, our scale factor is 2, and if you were to take a look, the original point was 1, 1 here for a, it's now 2, 2. 1 times what is going to equal to 2? 2. You could also take and do the find your scale factor by saying, let's take side B, AB right here. That's 1, 2, 3, 4, 5, 6. That would have been 6 pieces over 1, 2, 3. 6 divided by 3 once again gives us a scale factor of 2. Let's keep moving. The values for scale factor k determine whether the dilation is an enlargement or a reduction. We've talked about that. Or if the dilation does not alter the size at all. A dilation with a scale factor of k will be an image larger than the original if k is greater than 1. We've been talking about this. It's going to be smaller if k is going to be greater than 0 but less than 1. Remember, k can never be a negative number, and there's going to be no change in that dilation if k is going to equal to 1. Now we're going to look at each of these dilations and tell what's going to happen to your image from your pre-image. 2/3, that's a number less than 1. That means your new image is going to shrink from the pre-image or be reduced. 6, greater than 1, that means your new image is going to be an enlargement from your pre-image. And 1, that's exactly 1, that means your new image is going to be the same exact size as your pre-image. Triangle ABC has these vertices. Graph the image of the figure after a dilation of a scale factor of 2. That means you have to take every single one of these numbers and multiply it by 2 to find the coordinates of triangle A prime, B prime, C prime. Let's take a look at how we're going to end up doing that. So the point A is going to end up becoming, when we multiply everything by 2, 2 times negative 2 is going to be negative 4, comma space, 2 times 1 is going to be 2. We're going to accept that. The next points here is going to be multiplying negative 4 5 times 2. So negative 4 times 2 is negative 8. And 5 times 2 is going to be 10. We're going to accept that. And then for part C, I'm going to take and multiply each one of those by 2. 2 times 3 is going to be 6, comma space. 2 times 2 is going to be 4. Accept and check it. And now we have the coordinates of our new shape, our new image, after we've enlarged the pre-image. From here, they want to graph the coordinates of the new image, and you can see they've already done that for us. Actually, it looks like they started with the original image. Hold on. Yes, they started with the original image. They want us to do the new image, so I'm going to start with negative 4, 2. So let's take and pick a pretty color like red here. I'm going to do a start of the origin, negative 4, 2 for my first point. My next point is going to be negative 8, 10. So I'm going to go to negative 8 and 10 right there. And then my last point is going to be 0.64. So I'm going to go to 6 and 4 right here. Finally, we're going to take and connect those, A, B, C, and back to A. And now we have our new image, which they say is incorrect. I say they're wrong. Let me look. All right, it is indeed going to be correct, so that for some reason they're grading improperly. That looks like a good place to end part 1. Come back in part 2 when we're going to continue this study.